Thank you so much for joining us today. We're here for a conversation about how to spark math conversations using illustrative math in grades 3 through 5. And thank you for coming. This is going to be a webinar presented by 3 different organizations. There's ASSISTments, there's Teachly, and there's Worcester Polytechnic Institute, and they are actually the ones sponsoring this webinar. So a little bit about me. My name is Kara Carpenter, and I was a classroom teacher for many years. And I got very interested in the development of math thinking and how young kids sort of begin to learn and understand math. I sort of went back to grad school and I ended up getting a PhD in cognition and learning with that focus in early childhood mathematical thinking. And then sort of from there, I began to realize, hey, I've learned all of this about sort of what we know from the research about how kids learn math. And so I started a company, Teachly, and now that's what sort of I do is I develop math interventions for elementary schools that are really based in the research and the science of how we know that kids can learn and understand math. So that's a little bit about me, and I'd love to turn it over to Carrie, one of our other presenters.
Hello, my name is Carrie Moy, and I'm the program manager at the ASSISTments Foundation. Prior to this role, I actually taught for over 10 years in the classroom in Chicago, Illinois. I love seeing all the people coming in from Illinois. And I actually used ASSISTments and illustrative mathematics in my classroom. And I received my master's in education from Northwestern University and sort of had this passion when it comes to integrating technology in the classroom. And I'm really excited today to share some tools and strategies to help you facilitate math conversations in your classroom. I'm going to pass it off to my colleague Lee so she can introduce herself.
Hi everyone, my name is Li Chen. I'm a research scientist at Worcester Polytechnic Institute. I got my PhD in curriculum and instruction with educational technology emphasis, and a minor in research and evaluation methodology from University of Florida. My current research focuses on the design, development, and integration of advanced learning technologies to facilitate math learning. It's my pleasure speaking with you in this webinar. We're going to go ahead and start the presentation.
So you're here to learn how to spark conversations using illustrative mathematics in grades 3 through 5. In this session, we're really hoping that you learn about the 5 practices that support mathematical instruction, get to explore some free assessment tools that sync with illustrative mathematics, leave with concrete tips and strategies for improving your instruction, see different classroom conversations in action, and then at the very end, we're going to share some ways to pilot some modeling tools in your classroom to help students show their thinking.
Okay, great. So one of the things that we want to sort of start with is recognizing that having effective math conversations with students of any age, but especially with elementary students, can be sort of challenging. And so what we want you to do right now is write in the chat, like, what are some of the challenges you face in facilitating math talks in your classroom? What are some of the things that are hard about that? What are some of the things that, have you tried this? And some of the ways that it failed, some of the ways that it was just a really challenging thing to do. So if you can all go ahead and sort of put some of those ideas into the chat. Yeah, I agree. Making sure that you find the time to do this every day and to do it often. Oh, when kids have a lot of fear around their answers, especially if they're not confident. And we're going to talk today a little bit about sort of how to engage those learners whose solutions may not be quite perfect, but really wanting to make sure that we're engaging all kinds of learners in the conversation. So some of the challenges that we see, in addition to all of these that you all are putting forward, is that it's really important to build a positive classroom culture around conversations, helping students attend and notice, right? So that they can kind of recognize in somebody else's work What is a strength of that work? What's a weakness of that work? Where was the mistake? Where did the mistake happen? Sometimes there's even like the classroom setup or the space constraints. Do you have a space in your classroom where you can pull all of the kids to the rug? And is there a projector there where you can sort of project students' work? Or are kids all spread out around the room and sort of focusing attention can be more difficult? There's also just the issues of time and bandwidth, right? So basically, if I want to have a really good conversation about students' work, it's important that I have time to be able to take a look at that work and to sort of analyze it and really sort of understand what the students have done and where they need help. And sometimes the content itself can be challenging to explain or even for ourselves to understand, and sort of some of these techniques around sort of what to say in the moment. So these are some of the things that we want to sort of address today through this presentation. And we're going to be organizing this presentation around sort of two main areas of like, number one, thinking about what are some just strategies that I can use to help with these conversations. These strategies can be offline. These strategies can sort of connect in with technology. But then the second piece that we want to share with you are some technologies that you can use in your classroom to really help support these conversations and help support you in this process. Okay, then I'm going to pass it over to Carrie again.
Yeah, and so we're going to anchor these conversations using the Illustrative Mathematics curriculum. And so the Illustrative Mathematics curriculum is a comprehensive, standard-aligned curriculum developed to support K through 12 education. And it's really based on the idea that students are capable of using what they know to learn and solve math problems. So the resources in this like free open source curriculum are designed to focus on students' mathematical understanding and their problem-solving skills through an active engagement, collaborative discourse, and exploring multiple solution strategies. So basically, in an IM classroom, you're going to see students working on the problems, showing strategies to each other, and you're going to know that their experiences and ideas are valued. So how does illustrative math actually do this, you might ask? Well, it's through this idea of their instructional routines. There's notice and wonder, number talk, which one doesn't belong, and the 5 practices, just to name a few. We're going to focus today specifically on the 5 practices. So what are the 5 practices? Well, they were developed by Margaret Smith and Mary K. Stein, and it's emerged from research on effective mathematical teaching practices and classroom discourse. It's basically a way for students to engage with a problem in a meaningful way, and teachers essentially have a structure to have a student-centered classroom. It really allows the teacher to monitor and uncover and nurture conceptual understanding in students. So the shift goes from a teacher-led instruction to student-centered exploration and discussion. And so the 5 mathematical practices we're going to go through today are anticipating. This is where you are able to think about how your students might respond to a mathematical task. Then you're monitoring. You're actually walking around the classroom, listening in on students' responses while they're working on the task in small groups or in pairs. You're thinking about what you're trying to look for things that you anticipated early on and different solutions or alternative solutions students came up with. Then there's selecting, where you're going to choose specific student strategies that they use that you want to highlight during your whole class discussion. Sequencing is where you actually take those strategies that you've selected and put them in a specific order to present. And connecting is taking all those different strategies and connecting the ideas to help you meet a specific learning goal. Now, this is a lot, but I'm going to pass it off to Kara to give us a specific problem example that we can anchor in.
Yeah, okay. So we're going to see what each of these look like with this particular problem. So the first step, again, is anticipating. So I'm going to read this problem, and I want you to be thinking about and writing in the chat, what kinds of strategies do you think students will use to solve this problem, and what kind of mistakes do you think they will make? So this is a problem from a 3rd grade illustrative math unit. So Han had 558 beads. His sister had 302 beads. They combined their beads for an art project that used 250 beads. How many beads do they have left? So again, I want you to think about not how you would solve this problem, but how do you think your students might solve this problem? And what kinds of mistakes do you think that you might see in how they would solve those problems? I'm going to give everyone a minute to think and to write in the chat, what kinds of mistakes would you expect to see with this problem? Mm-hmm. I hope I'm able to see in the chat. Oh, okay. Okay, yes, now they're coming in. I think I had some kind of delay. Okay, yes. So one thing that you might see is the students see how many beads do they have left. And so they might just subtract all three of those numbers. So they might start with the 558 and then subtract again. Some students might add all of those numbers together, right? And because they're not trying to make sense of what's happening in the problem, they're just taking the numbers and doing something with it, which is oftentimes what we see. So then what I want to be thinking about, so I've anticipated that. And so when I'm going around the classroom and I'm monitoring the work that students are actually doing, I'm trying to kind of fit into my anticipation, right? Or those strategies that I anticipated, right? And so one person mentioned that they simply might just add all of the numbers together. You can see that like the student number 2 in this digital model that they made, they just added the 558, the 302, and the 250. And because I anticipated that, I know, okay, well, that's a strategy that I kind of expect to see. And so you kind of, the anticipating and the monitoring kind of go hand in hand, if that makes sense. Okay, and then when we're thinking about selecting work, okay, Margaret Smith talks about sort of the difference between show and tell conversations and orchestrated conversations. Now, a show and tell is basically you ask only the students with the correct solutions to share. You're like, okay, student 1 seems to have a good solution to this or a good model of this solution, and student 5 seems to have a good solution and a good model to this. So you might show different strategies, right? One of them used a tape diagram or bar model. One of them used an open number line, but we don't really highlight what makes one better than the other. We're just always kind of showing the good solution and hoping that by seeing that, the kids who made mistakes will be like, oh, that's different than mine. This is how I could change mine. The problem with that kind of approach is we don't really help kids sort of, number one, go from where they are, which may mean that they made a mistake, right, to where they need to get, and that they don't necessarily see how solutions can build on one another. And they don't get a chance to kind of recognize errors and think about how to fix them. So instead, we want to be thinking about orchestrating a conversation. So when we're selecting work, we're looking for examples of both correct and incorrect solutions, right? With different strengths and weaknesses, right? That can build on each other. So, and then I want to think about once I've selected the work, let's say I want to highlight these 3 solutions. They've all happened to use tape diagrams. So my lesson isn't going to be about sort of tape diagrams versus number lines. It's just going to be about how to make the tape diagram model as strong as possible. Okay, so I might want to think about how might I sequence this work, right? So I might decide I'm going to start with that student number 2, right? And my goal for this student sharing first is to sort of recognize that the 250 beads, adding those onto the end isn't going to help me understand the difference. I need to actually subtract those beads, right? So I'm going to start with this work and we're going to have this conversation as a class, and I'm going to help sort of facilitate it so that students can recognize that that 250 might be not in the right place. And then I might bring up the student number 4, right? This model is interesting because they used multiple bars in their model, right? And they kind of gave each number, right, a different bar. And so my goal might be that I want to have students notice that, oh, I can sort of put multiple bars next to each other and then I can have those represent different things. But here, right, the student has identified that the difference between the sisters beads and the project is what I'm trying to figure out, when in reality, that's not quite it either. And so that's why I might end with this final piece, right, where I'm finishing with a strong model, right, but where you can really see, oh, okay, well, I take the 558, I combine it with the 302, but then I'm actually taking away those 250, and so I'm needing to find a difference there. That's a place where I could sort of finish with this model, but what's something that this student did not do very well? Their labels, right? Yes, they're all beads, but that labeling strategy isn't as effective as student 2 and 4, right? Who helped with their labels to really help you know, okay, these were Hans beads, these were the sisters beads, and these was the project beads, right? So even in my last example, there's still like things that student can actually learn from the first two. But does that make sense to everyone? Yeah. Okay. And then sort of, the final piece, I guess this should say connecting. Basically, the final piece of connecting, one of the strategies that I love to see are the anchor charts, right? That this can really help you to synthesize discussions. So if we just had this whole sort of discussion where these 3 different students shared, I might, on a big old poster, right, write out, like, what are some of the things we learned from this conversation? Well, with multi-step problems, sometimes using multiple bars can help show sums and differences if I need to be able to show both of those. And that it's really important for us to use color and labels. Both of those things can help us make our models much clearer. Mm-hmm. And so that's kind of a little bit of what all of the practices were, from anticipating, monitoring, selecting, sequencing, and the final one, connecting with the anchor chart. And then what we're going to be doing from there, right? So we have these 5 practices. Now we're going to think about and talk specifically about how do those 5 practices, how can they be supported by different technologies? And there are 2 main technologies that we're going to be focused in on today. We have the ASSISTments platform, which is a free math practice and assessment tool that already has inside of it all of the illustrative math content for grades 1 through 12. So I saw at the beginning some of you are actually middle school teachers. ASSISTments is useful for that whole span. And some of the amazing things about ASSISTments is students get immediate feedback on the problems as they're working through them. And as a teacher, you can quickly pinpoint sort of problem areas or places where kids are struggling. And then the other technology that we're going to feature today are the Teachly tools. At Teachly, we have a K-5 math intervention program. It integrates games, videos, ebooks. But what we're really going to be focused in today are some of those modeling tools and those problem-solving tools. Some of the visuals that I shared earlier were examples of work that students can make within those tools. And at the end, we're going to talk about an opportunity to pilot those modeling tools within the ASSISTments platform for free. Great. And now I'm going to pass it back over to Carrie to talk through these technologies.
All right, I'm going to first talk about anticipating. And anticipating is actually done. It's essentially a way where you're envisioning how your students might approach a question. So oftentimes teachers are solving that math problem in a lot of different ways. And so they're planning that out. And it gives you essentially, when you anticipate, more control over your student-centered classroom, because this careful planning kind of limits the amount of improvisation you need to do in the moment because you've done all this pre-planning. But that can be kind of challenging, right? Given time and things like that. So anticipating has actually done really well in the illustrative mathematics curriculum by just reading through the lesson plan. If you focus on the lesson plan and different activities, there's the narrative, the student responses, and the activity synthesis. These sections really help highlight what you might need to do when kind of putting together a 5 practices conversation in your classroom. I'm going to show you a quick video highlighting that lesson plan that you will find online and where that can be. So if you open up your lesson and find the specific activity that you want to highlight, in the narrative, it tells you specifically what strategies you want to monitor for. So how students might solve that problem, adding all the numbers together, forgetting to subtract, those kind of options. And in the student responses, it gives you the actual strategies students might use. And then the activity synthesis provides you exactly how you might want to select responses and sequence them for your discussion. So that really helps you sort of anticipate what you need to do in your lesson to have a 5 practices conversation. Now I'm going to focus a little bit on monitoring and how technology can help you with monitoring. So it's really of how monitoring is how you can pay attention to student thinking on a particular task, while at the same time, you have to know if students are off track and get them back on track, right, or on the correct pathway, and then press students who are on the right course to think more deeply about what they're doing. It's a lot to happen all at once. And so this is where ASSISTments can actually help you. In ASSISTments, students are doing assignments online. And as a teacher, you're getting this data report. And in this data report, you see green for students got it correct in the first time. You will see orange with a little X, meaning they needed help on the problem, like an embedded hint that we have in our system, or they tried it and got some feedback and tried it again. And that's kind of what orange means. They got it correct eventually on their own. And red meant they needed help. They had to ask for an answer. And so you're seeing this data in real time and allowing you to analyze this data early and often so you can find those students quickly that need that extra support and push onto the right track, and then find the students who are really understanding it, like student E or student F here, and push them more on their thinking. Why? Why is it that it's working this way? And get them to really communicate what it is that they understand about the math. So you can kind of quickly determine whole class, subgroup, individual needs in real time. So that's one way, essentially, you can monitor using technology like ASSISTments. The other way you can monitor, as Kara said, in ASSISTments, students get immediate corrective feedback. So when they enter in an answer, they're getting this feedback on whether or not their answer is correct or incorrect. And they're using that essentially to push their mathematical thinking. So I'm going to show you a classroom in action right now. And I'd like you to think about, how does immediate feedback support monitoring?
Okay, Leonard got 4 liters of orange juice. How many milliliters of orange juice does he have?
I think wait,
What?
you can get a little.
Okay. Well, I think what she was teaching us, she said that in milliliters, it's 100 less than the liters.
No, hold on a second. I think it's 1,000.
Means
So
right.
that means it's 1,000 and not 400.
What isn't it 100 for centiliters? I think it's for milliliters.
No, for centiliters, I'm pretty sure it's 100. For milliliters, it was 1,000.
Yeah, you can put in 400 and we can put in 4,000.
Yeah, I think it's 100.
So we can just do it
400.
Let's choose it. Okay.
Oh, 4,000 is right.
Yeah, I got 4,000.
Maybe y'all are correct.
So I'm going to give you a minute or two to think about how immediate feedback can support monitoring in the classroom. As those are coming in, I'm hoping some of you notice that essentially misconceptions are quickly identified, right? That student was like, oh yeah, you were right. And then that positive feedback for students reinforces and encourages their effective strategy, right? And then knowing their responses essentially will be given feedback right away kind of motivates students to participate actively in their classroom and their classroom discussions. And this active engagement fosters a deeper understanding of mathematics and retention of these concepts being taught. So we've covered anticipating and monitoring of the 5 practices. We've got selecting, sequencing, and connecting left to cover. I'm going to play a video next and ask in the chat, as you watch this video, what's the example or examples of the 5 practices that you see?
So we had a homework assignment where you had to do ACE 11C, which was found on page 18. One of the things I noticed when I looked at ASSISTments was that although the correct answer was 800,000 square centimeters, more than 1/3 of you answered 4,000 square centimeters as your first choice. And a lot of you needed hints to figure out why 800,000 square centimeters was the correct answer. So here's what I'd like you to do now. I'd like you to have a conversation with the people that you're sitting with and try to figure out first why 800,000 is the correct answer, and second, why did so many students come up with 4,000 square centimeters as their first answer?
All right, so what examples of the 5 practices did you see in this video? Seen some sequencing and connecting, some monitoring, these explaining results, and that's exactly it. There's a lot of different things because all the 5 practices are sort of integrated together a lot. And we chose actually selecting for this particular video. The reason why we chose selecting is because this teacher is particularly highlighting an incorrect answer that he wants students to discuss. So the goal that he selected, the goal of his discussion essentially is to figure out what the students to figure out why that incorrect answer was so enticing. And selecting isn't always about highlighting that correct answer. So how does technology help us do that? Well, in ASSISTments, you get this data report. And one of the things that you're able to see is something called a common wrong answer. And what that is students enticing first answer, right? And this kind of goes along too with anticipating, because although we might anticipate what students might answer, and when we're monitoring, we actually might see we've never anticipated before, right? And so this is kind of that example where technology can help us do what technology does best. It's highlighting this common misconception amongst your students. So then now this can become the goal for your discussion of like, why was that answer so enticing, right? And it also helps with the community in your classroom because you're showing your students incorrect ideas and answers still have value in our learning journey. So I'm going to go ahead and play this next video to see how the discussion went.
The clip that started this video is the launch to an activity where students are going to analyze a common mistake in a homework assignment that I discovered because I use ASSISTments. I noticed that more than 1/3 of students gave the same incorrect answer, and I wanted to see if the students could figure out why.
20 times 200. Times 200 again. Yeah. You had to squares, go factor.
So what are your thoughts? Why did so many students say that 4,000 was the correct answer? What do you think, Fran?
I think what they just did is with the scale factor, they might have just divided 200 by 1 and then just multiplied that by 20. And then that's nothing.
And that's how they came up with 4,000? All right. What do you think, Allie?
Well, I agree with Farhan, and I think the reason they do that is because they don't.
So essentially, ASSISTments can help us with that selecting piece. It's using this online practice and assessment platform to pinpoint student learning needs, right? The common misconception, and it identifies the goal for your discussion. Making those common mistakes easy to identify in real time help essentially fill those misconceptions quickly and early. All right. I'm going to go ahead and pass it to my colleague Kara to talk about sequencing.
Great. And so one of the things that within sequencing, right, is you're thinking about what are the different examples. So once I've selected a particular problem that I want to focus in on, and maybe I've even selected the particular work that I want to highlight, we want to be also thinking about like in what order am I going to show that work so that I can like build students' understanding as I work. And this is one of the more complicated pieces of orchestrating a conversation. And so we're again going to watch some videos and sort of talk through a little bit about what this looks like inside of a classroom. And we are also going to be talking about how technology can sort of support this. So with this, we're going to be taking a look more closely at some of those digital modeling tools. This problem is going to be talking about sort of how many eighths, the problem that kids are solving is how many eighths are there inside of 3/4. It's a word problem. I think they've got a 1/8 scoop and they need to figure out how many 1/8 scoops to equal the recipe. But one of the nice things about sort of when students are making their models digitally, like they're doing these drawings on the computer, is that they're quite clear sometimes to be able to see right away, oh, I can see what the student was trying to do. And I can also see what are some of the weaknesses in that model. And so I can see that the second student has a much more precise approach to how they're creating those eighths and those fourths, right? And the first student has a little bit more of a loosey-goosey model around sort of creating fourths and eighths. Those pieces aren't exactly equally sized. And so one of the things that a digital modeling tool can afford, right, is that they are clear and easy to follow models often. You do get insight into students' process, right? So you can see how were they thinking about the problem, right? Remember Han and his sister earlier? You could really see the different strategies highlighted. And yes, you can always like if you're wanting to project student work, you can use your Elmo and sort of, put that piece of paper underneath there and project it out for everyone to see. But we all know that sometimes those pencil drawings, there's eraser marks, they aren't, the student's ability to just create a clear model is sometimes limited by their sort of physical motor control. And sometimes their thinking is well beyond the drawing that they're able to produce if they're using pencil. One of the other things that I love to see is that students oftentimes have a lot of confidence in their digital models, and so they feel very proud of the work that they've done. They love that it's colorful. They love that it feels clean and that they are able to explain it. And these models can be really simple to revise. So we all know I made a mistake, the eraser marks all over the paper, or, oh gosh, do I have to start again? Do I have to do that all over again? Versus sometimes when you're working with a digital tool, it's much simpler to erase, to recolor, to repaint, to resize. And so we'll see some of these in action. So in this first video, what I want you all to be thinking about as you're watching it is, why do you think the teacher might have started with this particular work, right? And what strengths and weaknesses do you see in this student's model?
Could you tell us what you did first to solve this problem, Slay?
Yeah. So first I put 3/4 and then the 8.
Could you show us where your 3/4 are?
3/4 is here, and I put paint 3 paints and 8, and there was just 1/8, the 1, and that didn't really feel right, so I added 6 up to here, and that gave me 2.
Okay. You said you added 6. Could you tell us what you mean by that?
I added 5 up to here because and then
with your 1. Yeah. Okay.
Okay, so why do you think the teacher might have started with this particular work, and what were some of the strengths and weaknesses in those particular models? You can go ahead and write your responses in the chat. Mm-hmm. Yeah, I agree that it could very well have been a common sort of error. Kids lack precision oftentimes in being able to make those equal parts. And yeah, this teacher does an excellent example of getting students to sort of re-explain or to sort of talk about what do you mean when you said this? And can I sort of add into to that conversation a little bit? From this point, the teacher did some pair shares, like what did you think about this model? And then had several students in a row sort of talk through what they learned from this particular student's model. And then this next video, fast forwards a bit in the conversation. I want you to think about and look for evidence that the teacher might have a sequenced plan for this discussion. So let me go ahead and share this next file.
Anybody else want to share how Soleia's model helps them know that we need 6 scoops? What do you think, Amaya? Come on up.
I think that since it's like, to me it looks kind of similar because it's like, it's only like a little right there and that wouldn't change anything. So I think it's the same because it looks the same, and if you like put like 2 of these, it could make that, and then 2 that, 2 that. It like kind of makes it.
Okay, Amaya, that's going to get us into our next strategy. Could we send some shine to Soleia, to Amaya?
Yeah, so when I see that, I can like see that moment and feel it myself of like, oh, she said exactly what I wanted some kid to say. I don't know if you've had those moments, especially when have been thinking hard about how you want to sequence these conversations. And sometimes students say exactly what you want. And sometimes they say exactly something that you're like, I have no idea what to do with that. But in this case, this particular student clearly is like, oh, she's drawing that connection. Did you see how her hand went like over? It's almost lined up, but not quite, but I can still see that it's 6. And then she starts talking about how fourths and eighths are related to each other, so that there are 2 eighths for every fourth. It's such an incredible, beautiful moment. And then that leads right into what this teacher was sort of hoping for into the next student's strategy, who was coming up to share. So as we're watching this particular video, I want you to be thinking about how does this work build understanding, right? So we saw the first student share, right? And then the next student came up and was like, oh yeah, it's kind of 6. And how we can sort of move from there. And so I'm going to play this next one.
Okay. All right. Sebastian, could you talk to us about how you solved this problem?
So what I did to use the ticks, I made 3/4, and then in between the fourths, I made tick marks to represent the eighths.
Could you pause for a moment? What do you mean by in between the tick marks?
So I put a tick right here, here, and also here, and here.
And why did you do that?
Because I knew that if we put it in because 4 is 1/2 of an 8, that means you have to put all of these in between the ticks that represent fourths.
Sebastian said that could you say the part about the 4s and the 8 again?
I knew that you could put tick marks between them to represent, and also on the fourths to make eighths.
Who could explain what Sebastian just said there? What does he mean by that?
And then this particular teacher goes on to sort of have other kids. You notice that this move, it can be really powerful. Like, let me try and re-say what I think that you just said, and get you to confirm it. Let's have other students sort of re-say what you just said. Let's have people turn and talk with a partner and try and re-say what you just said. All of these little moves can really sort of help students to build understanding. And if you had just started with this student's work, like the show and tell, like I'm only going to show the good solution, you miss all of that opportunity for students to realize, oh, instead, if the first student had taken those 3/4 and had kind of tried to think about just splitting those into eighths in a proportional way, like the ending model would have been a lot more clear. And so it's just a really sort of nice example of how you can sort of sequence, right? Take kids from where they're at and really help them build into the next piece. And some of the other things that I hope that you all noticed is like, one of the things that I love about that first video is the girl who shared, even though her model wasn't perfect, like the smile that she has on her face when they're like, oh, share some shine with so-and-so. Like, this doesn't have to be something where students feel bad at the end of it, right? We're all learning, we're all sort of working, we're all growing with each other. And a lot of that is sort of establishing sort of classroom practices that support students in feeling good about their math. So the final practice, again, is sort of connecting. And with this practice, I want to use a little bit of the technology that we have right here. We're in an EdWeb webinar that has hundreds and hundreds of teachers from all over the country, all over the world. And I want us to sort of utilize this technology to help share some strategies of what you do in your classroom to help students make those connections. So right in the chat right now, I want you to be thinking about, what did you notice this teacher doing to help her students make connections? Or what are your favorite strategies to support students in making connections? One of my favorites I shared earlier, it's like the anchor chart. It really helps. I can put that up and we can refer back to it later, and we can say, yeah, these are some of the things we learned about sort of how to make models. These are some of the things that we learned about how to approach problem solving together in our class. And so if you all can sort of write down in the chat, what are some of your favorite strategies to support connecting? And while you do that, I've put together some of my favorite prompts that I got, many of them from this particular sort of teacher in the full video, and others from just working with teachers around the country. Some of my favorite discussion prompts. Especially, I like thinking about sort of the different things that sort of we can do in a discussion. Sometimes we want to expand on what students have there. Is there a different way? Can you tell me more? Also be thinking about explaining, like, is this always true? How would you show me? What do you notice that's similar or different? These observations and these reflections. So this is just a little bit to share. And I know this is a lot of information, so don't feel like you have to write it all down now. All of these slides will be available in your sort of EdWeb portal. So you can get access to them at a later date. Great. And then we're going to sort of next be talking about the technology, right, that's going to support the 5 practices. And we've got ASSISTments, which again is a free tool that integrates IM curriculum. It also has the Engage New York curriculum for 1st through 12th grade. Students get immediate feedback. You get the formative assessment data. What were some of those common wrong answers? What were some of the things that your kids struggled with? And then thinking about the Teachly tools, we have a broader intervention, but today we're focusing in on these digital modeling tools that students can use to show their thinking. Oh, I love how even within this chat, people are adding on to other people's ideas. Yes, so use this as a resource because we're all sort of here together. And then I'm going to pass it back over to Carrie to tell you more about ASSISTments.
All right, so like Kara said, ASSISTments is a free math practice and assessment tool. If you wanted to go to assistments.org right now, you could click the sign up button and create an account. That really empowers teachers to target your class instruction, monitor learning, and intervene quickly. A fun fact, Christina Heffernan, who is our co-founder and executive director of ASSISTments, was actually a student in Margaret Smith's classroom, like the developer of the 5 practices. So she was actually a student, became a math teacher, and then built ASSISTments. So just a little fun fact. But how ASSISTments works is, there we go, is a teacher can assign online from the Illustrative Math curriculum. So what we have in ASSISTments mirrors your curriculum exactly. It's got your classwork, your practice problems, and your cool downs all available online. We also have the assessments both in English and in Spanish. And so those are available for you to assign to your students. Your students will get immediate feedback on their problems, as well as there's embedded hints and explanations to help push their thinking so students can opt in to receive a hint. And then you get all of this data. You can see exactly what students entered in, how many times they tried before they needed to ask for help, what kind of help they received in terms of the hint, and how that pushed their thinking forward. And then you can essentially use this data to build that discussion with students. You can actually show the data report. There's a way to anonymize the data so that you will not see student names, and it's all digitized, kind of like what Carrie said about the modeling tools. Students won't know. And you'll see this data, you can project it up to in class, and then students can talk about it. I had my students talk about common wrong answer a lot. I used my favorite no, that's what I called it, but that would become our discussion. I think somebody called it a beautiful mistake. And those are great ways to kind of build in that discussion. And ASSISTments finds that for you. Instead of going through a bunch of papers and being like, I think this is what most of my students are answering, the data and the technology will tell you, hey, your students have this as a misconception. And you're like, great, I will talk about that in class next.
Now that you have Thank you, Carrie. Now that you have heard a bit about assessments, we would like to highlight the evidence of the impact of assessments, because it's a free tool that you can use to enhance the 5 practices. Assessments is one of the few math edtech tools with Tier 1 rating, which is the strongest rating by evidence for essay. According to a case study conducted by researchers at Columbia University, teachers who used assessments spent less time grading, and they were able to target their instruction more. And on average, assessments saved teachers 30 minutes daily. Assessments also have had strong impact on students' math learning. An evaluation by 3 International found that classrooms used assessments achieved 75 more learning than classrooms that did not use assessments. Assessments not only has impact on students' math achievement, but also on equity. In a recent evaluation conducted in 2018 to 2021, it was conducted with 63 schools and nearly 6,000 7th graders to examine assessment's impact. It was found that 1 year after the intervention, students who used assessments scored significantly higher, and students in marginalized communities had the greatest growth in math learning compared to students who did not use assessments. So I'll pass it to Kara to talk about Teachly.
Yeah, so at an overview of Teachly, we have a sort of a K-5 math intervention. There's very flexible delivery, sort of by the classroom teacher, pull out, push in lessons, games, stories, and modeling tools. And the modeling tools are the sort of what we sort of featured in today's presentation. And there's an opportunity to sort of pilot these modeling tools free within the ASSISTments platform. And Carrie is going to show you a little bit about what that actually will look like.
Oh, okay. So I'm going to go ahead and play a quick video and show you how these tools are embedded in ASSISTments. So in the student view, students can then see the modeling tool. They can use the colors that Kara talked about, pull in the numbers that they need, kind of develop their model and their thinking. They can submit it and then use ASSISTments to kind of get that immediate feedback, so things that they're used to. As a teacher, you get the data report that is familiar with ASSISTments, but you're actually able to dive into these modeling tools and see student thinking, so then you can choose and select specific ones that you want to highlight. So this is an integration that we've just put into ASSISTments. And I'm going to pass it over to Lee to talk about how you can join us in this pilot opportunity of this integration.
Thank you. So the ASSISTments and the Teachly tools provide great opportunities to support the 5 practices and spark conversations in math classrooms. We have this pilot opportunity to study how these tools support the 5 practices and how they impact students' math learning. So the pilot study will be conducted in fall 2024 with 3rd grade math classrooms using illustrative mathematics. If you teach 3rd grade math and are interested in trying out the tools, please feel free to click the link in the chat. Let me put the link in the chat. So, and we will provide training to help teachers use assessments and Teachly tools to support the 5 practices. If you teach a different grade and would like to try out these tools, you can still sign up, and we may have other opportunities to pilot. So that concludes our presentation. Do you have any questions? Please feel free to post in the chat.
I'm going to address some of the questions that have come in. One sort of person shared, I usually sequence from the most concrete to the most abstract, but you sequence by goal. Both correct and incorrect responses, question mark. Yeah, sometimes it can be helpful to think about sequencing from concrete to abstract. That might be like if your goal is to really help support students from going from the concrete into thinking about those abstractions. But sometimes you want to be thinking in a little bit, in also a nuanced way. And yes, I think it's really important to consider both correct and incorrect responses, and to really facilitate a feeling in your classroom that like, it is okay to make mistakes. One of our teachers, what does she say? A mistake is the moment where your brain is growing the most, right? Like it's you're finding that moment of the aha, right? Because if you didn't ever, if we're never making mistakes, it means that we're not really challenging ourselves. We're always staying with what's easy for us. And so that's like, if you're never making a mistake, I know you're probably not thinking hard enough. You're probably not giving yourself enough challenge. And so when we are making mistakes, it's that moment that you can really grow and learn. And then, somebody asked, with practice, do students eventually speak louder? Yes. Well, and in these videos, you notice that we closed caption them all because sometimes it can be really challenging to hear what students are saying, especially with these mics. When you're actually in the classroom, it's often a lot easier to hear and to understand. And then someone asked, is ASSISTments free for a whole year or longer? It's a forever free account. And so it's not something that you will sort of ever be charged for. And then would you suggest that students use this over the summer to help with learning loss? Yeah, there's definitely I can speak with our Teachly math intervention is definitely something that students, when they have access over the summer, especially the games, the videos, those high engagement materials that students can use on their own. The modeling tools, it's oftentimes something that's best done with sort of a teacher's guidance and support as students are working through problem sets, sort of together as a class and having these conversations. That being said, if you've got a summer program or a summer school, it can be a great time to try things out. Awesome. So if there are any other questions that you can all sort of let us know. Oh, I love, if you can't make a mistake, you can't make anything. Oh, I love that, Susan. Yeah, no, that's a great, yeah. The celebration of the fact that we're making mistakes, that mistakes are part of the learning process is just really key. Mm-hmm.
And then before you leave, I'm just going to also answer for ASSISTments. Yes, I think it can definitely help with students over the summer with learning loss because we have the embedded immediate feedback and embedded hints and explanations, but it really works well too because it's designed to keep teachers in the driver's seat. So having the teacher looking at that data, helping support students in their learning is really key to making it work as well. I'm going to quickly run a poll now and ask you what you'd like to learn more about. You're going to see it on your screen. There are a couple different things that you can mark on what you'd like to learn more about, either Teachly itself, piloting Teachly and ASSISTments together, learning about ASSISTments and getting your free teacher account, or as well as if you are a school and district leader wanting to learn about how ASSISTments supports schools and districts. All right, I'm going to leave that open for a few minutes here, because I've seen lots of answers come in, and I want to give everybody the opportunity to select what they'd like to learn more about.
Okay, and then EdWeb also just posted a little evaluation. So if you want to share feedback with us about sort of, did you appreciate the webinar? Did you learn something from it? Do you have something specific that we could do to improve? We would really appreciate that. Thanks again, everybody. Much appreciated.